Okay, so good morning. We're starting section 4.2, logarithmic function, but before that, we will review sample test chapter 3. So let's share the desktop. All right. Okay, so math 260. All right, good. So sample test chapter 3. Number 7. So you have the zeros, which is 1, -2, 3, and P of 2 is equal to 16, right? So what you want to do is, let's just do the zeros. So what is P of x? X minus 1, x plus 2, x minus 3, and then you're going to put a constant here, a. That's the only difference because P of 2 is 16, so we have to find a later. So if you have P of 2 is 16, so P of 2 is equal to a times 2 minus 1. What is 2 minus 1? 1. 2 plus 2, which is 4. And then 2 minus 3, which is -1. Yes. So 16 is equal to, what is it, -4a? Yes. So a is equal to -4. All right. Good. So basically your function is -4 times all these, so you could just multiply. Yeah? Does that make sense? So P of x is equal to -4, and then you're going to multiply these. Does everybody know how to multiply these? You have to multiply it out. Yeah? What is the answer after you multiply it up? Did you try it? Okay, what is the answer after you multiply these out? X cubed minus 2x squared plus minus 5x plus x? Minus 5x plus? Okay. So if you multiply these out, then this is what you get. So you could leave it like this, or you could distribute the -4. Yeah. So basically, this thing, P of 2 is equal to 16, is only giving the coefficient, this part. All right? Okay. Now, what next? You said number 11? Okay. All right. So number 11. So this is based on the graph. So if you don't have your sample test in front of you, it's probably going to be difficult. So based on the graph, can you tell me what the zeros are? -1? Before -1, there is something else here. Is it -4 or -3? 1, 2, 3, 4. -4? Okay. And then what else? By the way, what is the multiplicity of the 0 and -4? Even or odd? Odd. So most likely the multiplicity is 1, right? So -4, the multiplicity is odd. Okay. And then what? -1. What is the multiplicity? Odd or even? Odd. And also 1, the multiplicity is odd. Yeah. So then you have a choice here. So you have all the zeros. Then what would you do? You think the coefficient is positive or negative? The leading coefficient. Leading coefficient is positive. Why is it positive? Why is it positive? Because the end behavior, it starts at low and ends high. Yes. So that's what you know so far. So if you have to construct a function, then what would you do? And I know the other one is 0, what is this? 1, 2, 3, 4, -5. So y-intercept is 0, -5. Yes. All right. Okay, good. What would you do now if you have to find the function? So P of x would be what? X plus 4, x plus 1, x minus 1. Yes. So this is x plus 4. What is x plus 1 times x minus 1? X squared minus 1. Okay. So what is x plus 4 times x squared minus 1? X cubed minus, what is it? Minus x. So x cubed minus x, is it minus x? X cubed. Yes, plus 4x squared minus 4. Oh, so there is no answer here? 1, 2, 3, 4, 5. Is that what you're saying? Oh, okay. Because so this is a mistake, right? 1, 2, 3, 4, 5. Okay, I see what you're saying. Yeah, so the answer is supposed to be this, and then let me see. Is this correct? Because your zeros is 4, 1, and negative 1. Yeah, there is no answer here. I think the graph wasn't done correctly, unless
the D is closest to
the D is the closest one, yeah, but that's not the correct one, yes. So this should be the correct answer. Unless your graph is wrong here, the zeros is not negative 4, but negative 5. So there is a little bit wrong here with the graph. The zeros is supposed to be negative 5, right?
But if you use 1, 0, or you substitute to the function, you get negative 1 or 1 negative 1.
1 and negative 1?
Yeah, if you use 1, 0, substitute the function, negative 1.
But not negative 5, right? Not
negative 5.
Yeah, this one is not correct. So I think probably the graph here is not exactly as negative 5. Do you see it here? Yeah, so the graph here is not exactly negative 5. So I think this is probably not the correct solution, the correct answer. But of course, the closest one is D. Probably this is the answers in the back.
Yeah.
Yeah. Okay, but no, not this is not correct actually. Yeah. Okay. Oh gosh, I didn't know my sample test has mistakes. What about number 12? It looks something like this. Were you able to factor for number 12? So here, I guess it should have been negative 5. Yeah. All right. So the zeros. There's something wrong with the graph. What about number 12? Were you able to factor it? So number 12. What about number 12? Were you able to factor it? By looking at the graph? Yes. So how are we going to factor it for number 12? Yes, so the zeros are what? Negative 3. Negative 3 multiplicity of 1, and then 2. Multiplicity of 2, yes. So what is the graph? How would you factor it? X plus 3, x minus 2 square, yes. And is the coefficient positive or negative? Leading coefficient. So yes, this is x plus 3, x minus 2 squared. Because sometimes you have negative, but you have to look at the end behavior, but this is not the case, right? Based on your end behavior, the leading coefficient is positive. Yeah, yes. Look at what happens at 2. Does the graph touch or does it cross? Because it touches. Yeah, so touches is even multiplicity. Yeah, so good question. Why do you know this has a multiplicity of 2? How? Because the function touches at 2. X-intercept equals to 2. Yeah. All right. What else do you want to talk about? I forgot. Was it 26? 21, 26? Okay. Oh, where is my... Okay. That's disappeared. Oh, hold on. Oh, here it is. Number 26? 21? Oh. How many positive real zeros does this graph have? What was the answer? 2, yes? You can just see it from the graph, don't you? So, number 21. So, how many positive real zeros does this graph have? 2, right. You can see it from the graph, can't you? Yeah, but we don't know because this is approximate value. It's between 0 and 1 of them, and the second one is between 4 and 5. Do you see it? Yeah, okay, so 2. Did I ever discuss intermediate value theorem? So it's like number 15. Yeah. So let me discuss that a little bit. So number 15. Use the intermediate value theorem to show that the polynomial has a real zero between the given values a and b. So what is the intermediate value theorem? So intermediate value theorem. So this is what it says, remember? So if f of x is a continuous function and on AB, so this is an open interval AB, yeah. So if f of x is a continuous function on AB and f of A and f of B have opposite signs, then there is at least 1 0 in AB. All right. So let me illustrate what I mean by that. So I'm going to wait for you, because this is an important theorem, and you'll see it again. Yeah. So we skipped number 16, right? Okay. Because that's a cubic function. You could do it using graphing calculator. Okay. So you have to look at the graph and then see which one is the maximum for number 16. But we can't do it without graphing calculator. So if f of x is a continuous function on an interval AB, and f of A and f of B have opposite signs, then there is at least 1 0 in AB. So if you have continuous function, what does it mean? The graph will be continuous. So something like this is a continuous function. So let's just say this is A and this is B. So this is your interval, right? Now if one of them is below the x-axis and the other one is above the x-axis, meaning they have different signs. If it is below, what is the sign? Positive or negative? Negative. What about the above? Positive. So they have opposite signs. Then what happens? What does the theorem say? It guarantees that there is at least 1 0 here. So does it tell you where the 0 is? No. So this theorem only guarantees the existence of a 0, at least one 0. It can be more. So suppose your function looks like this, then you have more than one 0. So the theorem just says at least one 0. Yeah. So now, what do you have to do for number 16? So basically, you have to prove that there is a 0 in between -2 and -1. So what it is saying was there is a proof that there is a 0 in -2, -1. So what are you going to do? Well, first, you have to state that the function is continuous. Yes. So this is the elements of the proof. So f of x, so this is how we answer it. F of x equals to 4x to the 5th plus 3x cubed plus 2x squared plus 10 is continuous on all real number. This is a polynomial function. It is continuous on real number. What is f of -2? So you have to calculate. So 4 times -2 to the 5th plus 3 times -2 cubed plus 2 times -2 squared plus 10. What is this? Negative what? 134? Okay. So this is less than 0. Right? Now, what about f of -1? Well, then you do the same thing. 4 times -1 plus 3 times -1 plus 2 times 1 plus 10. So what is this? Is it positive? 5. So 5 is greater than 0. Right? Yes. So since f is continuous on R and f of -2 and f of -1 have opposite signs, there is at least a 0 in -2, -1 by intermediate value theorem. I usually just write IVT. Right? So there are a few things. So the first thing is continuous, and then opposite signs, and then you have to mention the theorem, at least a 0, and then by intermediate value theorem. Okay, so you'll see this again in calculus. This is very common. So you need to know what intermediate value theorem. And then in calculus, there's also mean value theorem, yeah, which is closely related to intermediate value theorem. All right. Okay, what else? One more? 26. Wait, is that the last one? Yeah. Okay. Good. And then we could start 4.2, right? How about the graphing? Were you able to graph, for example, number 13, 14? Were you able to graph all the functions? Yes? Okay. And when you graph, did you follow the steps that I asked you to do? Because on the exam, I always ask you, what is A, B, C, D? Yeah? Okay. All right. Good. How come it doesn't work? Hold on. 26. This is, what is this called? Variation, isn't it? Yeah. Okay. What's difficult about this? So the resistance of a wire varies directly as the length of the wire and inversely as the square of the diameter of the wire. So you guys don't have sample tests? Sample tests? Okay. But you need to bring it because we discussed it in class, right? I mean, like, I don't copy the problem. That's why. Yeah. All right. So R is equals to varies directly as the length of the wire. So what does that mean? So K times L over D squared. So it says that varies directly as the length of the wire and inversely as the square of the diameter of the wire. So that's why is L on top and D is on the bottom? Inversely. And why does the D have a square? It is stated that inversely as the square of the diameter of the wire. Right? And then a 20-foot length of wire. So what is that? What the length? So L is 20 feet. Okay. Diameter is 0.1 inches. Has a resistance of 3 ohms. So R is 3 ohms. So what are you going to do? Oh, this is the symbol for ohms. Let me just write ohms. Yeah. Okay. Hi. Who is it for? Oh, it's for tomorrow, right? Okay. Oh, okay. Can you come back tomorrow? Okay. Thank you so much. So you're running around? Yeah. Okay, so I'll see you tomorrow, yes. Okay, so anyway, what would you do in this case? Find K, all right. So you're going to substitute, so this is given. And you need to find, okay, what would the resistance be for a 42-foot length with diameter 0.01 inch? So find R when L is 42 feet and then D is 0.01 inches. All right, so you have to find K first. So R is 3 is equal to K times 20 divided by 0.1 squared, is it? Yes. So you're going to get K, right? Yes. No, we ignore the units. Yes. As long as, so there is a good question. Do you need to convert the feet to inches? No. As long as these units for the length are the same, this D is the same, the R is the same, there is no need to do unit conversion. Yeah, so good question. There is no need to do unit conversion as long as the length is the same and the diameter is the same and everything else is the same. Yeah. So what is K here? And then R is equal to whatever K you get, L over D squared, and then we substitute. Does that make sense? That's how we do it. Yes? Can you tell me what K is? 0.0015. So this is your equation of variation. Then what would you do after we have the equation of variation? We substitute. So R is equal to 0.0015 times 42 divided by 0.01 squared. I don't know what the answer is. So, but there will be, and the unit is ohm. Yes? Okay, good. Shall we start 4.2 now? Yes. All right, 4.2. Okay. Are you ready for tomorrow's test? No? Sort of? Okay. Who's ready? Okay, Sophia, good. So I expect 90, a lot of 90s, yeah? I don't purposely make my test difficult. You saw that, right? Yeah. It's just that you need to know the material, the type of questions. And I gave samples, so I think it's pretty fair, isn't it? Yeah. So if you studied the sample and notes, then I'm sure you'll be able to do fine. All right, let me save this first, and then we will start. Save as. Okay. All right. So, 4.2 is logarithmic function. I saw that there is a share here, file share. Is it easy to share it? Or share across device? Or send it? Like, how do I share it? Can I put it on Google Drive so you guys can access it or something? Oh. Oh, really? Okay, but probably easier to share it to Google Drive, right? Does everybody have OneNote or no? Oh yeah? So does everybody have OneNote? No? Yes? Who doesn't have? No, you have a, how do you say this, every student has it? You guys have Office 365 as a student? Oh wow, okay. Oh wow, because I do have Office 365. Yeah. Okay, so let's figure that out later, okay? Because I mean, it would be nice if I could share the notes, right? For you, yeah. But I need to do it so that it's easy for me too. Yeah, and not too complicated, because otherwise it's probably a lot of work. But it's just as a matter of click and then share, then I would be willing to do it. Okay. Anyway, let's continue now. Oh, sorry. Go to home. Logarithmic function. All right. Okay. So the log function with base A. So the log function with base A denoted by log base A of x equals to y. This is equivalent with A to the y is equal to x. So I have to write here log base A of x. The log function with base A, denoted by log base A of x, is an inverse of an exponential function. With base A. All right, that's what I was going to write. So the log function is an inverse of an exponential function. Yeah. So what do we do when we find inverse? Do you guys remember? Yes, switch the x and y. Yeah. So let me explain a little bit. Why do I say that the log is an inverse of exponential function? Okay. So suppose this is an exponential function, a to the x. Y is equal to a to the x. This is, what type of function is this? What do we call this? Exponential function? Yes. How do I find the inverse? So y equals to a to the x has inverse. You switch x and y, x is equal to a to the y. So you're practically switching x and y. Now, if I ask you, how do I express this in terms of y? Because I want to say y equals to something. So if I have x is equal to x with a to the y, I want to express it in terms of y. Y is equal to what? So this is where the log came from. So this is actually the dot 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 portion here is log base a of x. Yeah, so this is where we introduce the notation of logs. Okay, so these two are equivalent. That's what we wrote here. Now, a few observations. Okay. The base of the log is equal to the base of the exponent. So base of log is equal to the base of the exponent. All right. Now, is there a restriction on A? Last time, is there a restriction on A for these? Do we have a restriction on A? Yes. A has to be greater than 0, and also A cannot be equal to 1. So the restriction still stays the same for A. Yeah? We had that last time for exponential function. If you look at yesterday's note, then it's the same. Yes. So what we want to do is rewrite as exponent. So rewrite logs as exponent. All right. Number 1. Log base 5 of 125 is equal to 3. And then log base 4 of 1 over 16 is equal to negative 2. So how do we rewrite this? Yes. So the base of the log, which is 5, and what's the exponent? 3 is equal to 125. All right. And the second one? The base is 4 to the negative 2 is 1 over 16. What about if I have log base A of B is equal to C? Yes. So the base of the log is A, and then the exponent is C is equal to B. What about if I have P is equal to log base B of W? What is it? B to the C is equal to W. Okay. So this is doable? Yeah. Okay. Now, what about if you rewrite? Rewrite exponent as log. Okay. So, all right. So suppose I have 3 to the x is equal to 1 over 27. Or if I have a to the b is equal to c. And if I have x is equal to 4 to the y. I want to write these as logs, so what should I do here? Yes. X. 3 to the x. So how would you write these as logs?
Log base 3 on 27 x.
Yes. Oh. So log base 3 of 1 over 27 is equal to x. Yes. Okay. What about a to the b is equal to c? Log base a of c is equal to b. And then the next one, log base 4 of x is equal to y. Yes? Okay. Now let's calculate some simple logs. Okay. Are you guys okay? Yeah. Continue. So tomorrow we have a test, right? Would you please bring your Chapter 3 homework portfolio? Yeah, Chapter 3 portfolio. And what? A scientific calculator. Yes. I have one, but I only have one. So if you want to borrow it, I only have one. So you need to bring your own. Yeah. And no graphing calculator, no cell phone, or no Apple Watch or whatever. Yeah, no electronic device. Basically, you can just use scientific calculator. Okay. So calculate the exact log. So number 1, what is log base 2 of 8? No. So this is asking the question, 2 raised to what number? Gives 8. So what's my answer? 3. So actually I could write it like this, 2 raised to what number gives me equals 8. That's the same thing, 2 raised to the 3rd power. And then I could ask you, what is log base 3 of 1 over 27? So what is it am I asking? 3 raised to what number gives 1 over 27? What's the answer? Right. So basically, if I want to write it differently, 3 raised to what number equals to 1 over 27? And the answer is -3. Okay. Right? Number 3, what is log 0.001? By the way, if I don't write the log, what is it actually? Log base 10. So this is actually log base 10. So later on we will talk about this. So what's my answer? So they're equal here. These two are equal. Yeah. So what's my answer? -3? Yes. Good. So basically 10 raised to the what will give you 0.001. And the answer is -3. Right? Okay, good. So we can calculate that. Now let's talk about some properties of log. So properties of log. What homework due tomorrow night? Only 4.1. Yeah. I don't think it's long. Yeah, I think it's short. Did you see it already? Homework 4.1? No? Yeah, is it short? Okay, but it's fast, right? Not long. It doesn't take that long. Yeah. Number 1. Log base A of 1. So tell me, what is log base A of 1? 0, yes. Why? A raised to the what gives me 1? And the answer is 0, yes. Good. So log base any number of 1 is 0. Yes. 2. Log base A of A. So how do I answer this question here? A raised to the what gives me A? 1. So this is 1. You're right. What about number 3? Log base A of A to the x. And then I want you to fill this out. All right. Yes? So what's my question here? A raised to the what is equal to A to the x. So my answer will be yes. Yeah? Okay, good. Now the last one here, number 4 is A raised to the log base A of x. This is also equals to x, right? Okay. So let me see how I could explain this to you. A raised to the log base A of x. I think you have to let something, and then let me see how I could explain it to you next time. Okay? Because this is not using what we used before. So A raised to the what is give me x. Yeah. So let me explain this to you next time. Okay? Okay. Let's see. What else should I say? Okay. Can we graph? Can we calculate a little more? What about something like I forgot these. So this is number 1, 2, 3. What about log base 4 of square root of 2? This is a little difficult. Half? Okay, so how would you do something like that? 4 raised to the what is equal to... Okay, so, but this is hard to answer, isn't it? 4 raised to the what is equal to square root of 2. Yes. So how would you answer that? You're right, but let's answer this. So what would you do? So in this case, what you want to do, instead of get this number directly, okay, and we will talk about these more because this is actually an exponential equation. So what you would do is write an x here, and then we will solve for x. Yeah, so we will talk about these in a little bit because this is an exponential equation. So just pay attention to this. Okay. So 4 raised to the x is equal to square root of 2. So what is square root of 2, by the way? Can we write it as 2 to the 1/2? Yes. This is 4 to the x. Can I write 4 so that the bases match with this? 2 squared raised to the 4 to the x. Right? And what do I have here? 2 to the 2x is equal to 2 to the half. So 2x is equal to half. What is x? Yes. Well, I'm sorry, it's very small. Yeah. So if it is a little bit complicated to answer, then what we do is we assign a variable. Yeah. But we will talk more about this because this is part of exponential equation. So solving this is part of exponential equation here. Okay. So, but what you could do is assign x. All right. Now let's talk about the graph of logs, log base 2 of x, log base 3 of x, and then we will use common log and natural log. And 4.3 is laws of logarithm. All right. So let's start. So let's table this discussion to discussion a little bit. You will see this again, I guarantee you, later on. Yeah. So right now we will continue. So I think I have 8 minutes, right? 42. Yeah. That's too fast. My clock is 45 also. Is it 8:42 or 42? Okay. Yes. All right. Good. So B, what about if we want to graph f of x is equal to log base 2 of x? What would you do? Oh, you write it as exponent? Yes, that's right. So y is equal to log base 2 of x. Okay, good. How do we rewrite this x as exponent? What is the exponent here? 2 to the y is equal to x. So I'm going to write it as x is equal to 2 to the y. Yeah, so this is what I'm graphing. All right. So now look at this. Am I choosing x or am I choosing y? You choose y and you calculate the x. All right. So let's do that. So y and then x is 2 to the y. So what y should I choose? Can I choose negative? Yes, of course. -2, -1, 0, 1, 2. Now, very important here is because x and y are of different order, so we have on the last one we have to write down as ordered pair x comma y. Yeah, which one's x, which one's y. So what is 2 to the -2? 1/4. 2 to the -1. Half. Good. 2 to the 0. 1. Okay. 2 to the first power. 2 and 2 squared. 4. All right. Now this is x comma y, not y comma x. So I'm going to write it the order pair. 1/4 comma -2. Half comma -1. 1 comma 0, 2 comma 1, 4 comma 2. Yes, no? All right. So now we can just graph it. What is it here? Oh. Maybe I'll use this graphing for both log base 2 of x and log base 3 of x. So 1, 2, 3, 4, 5, 6. (1/4) comma -2 is so this is -2, -4, -6, 2, 4. Okay. 1/4 comma -2 is right here, and then 1/2 comma -1 is right here, and then 1 comma 0, and then 2 comma 1, and then 4 comma 2. So it looks like this. Actually, it's more paper out. Log is more paper. More like this. Yeah. So this is y is equal to log base 2 of x. Alright. So does it have vertical asymptote? Yes. What is the vertical asymptote? Yes, x equals 0, which is the y-axis. Can you tell me the domain and range? Yes. All right. Yeah. So actually, for any log function, x must be greater than 0. So y is log base a of x, and x must be greater than 0. Look at this. The graph is only half. So it's only the one to the right of the y-axis. Yes? Okay. So are we okay so far with the graph of the log? How about the graph is y equals to 2 to the x? Remember last time it looked like this? So this is the inverse, so it's going to look like this. Yeah. Oh, well, I mean, it's probably like this. Yeah, the inverse. So let me erase this, and we'll talk now on Thursday. Yeah. Okay. All right. So I will see you on tomorrow. We have a test, right? Yeah. No. Okay, guys. Study hard. Yeah. I have office hours today, 11:45 till 12:15. So.
Sorry.
So tomorrow test, and then Thursday we continue 4.2.